Hi dear students, welcome back to computer science class. We have already learned basic terminologies, modes of communication and switching techniques in our previous session. And switching techniques is one of the most important topics in data communication, and switching techniques like circuit switching, message switching and packet switching, right? And today we have two very important topics for discussion: data communication terminologies and network devices. Here also we do discuss on data terminologies, data communication terminologies. Of course, we will be looking at some advanced terminologies. Okay, then network devices like modem, gateway, router. Lot of devices are there. Actually, we will be looking at 10 specific devices. Okay, yes. Moving on. Okay, communication, data communication terminologies. We have channel first. Okay, channel. You know what actually channel is? Channel is a path that helps in data transmission. That's it. Okay, channel is a communication path through which data is transmitted from the sender device to the receiver device. That means simply we can define it as what? Channel is a communication path that helps in data transmission. Okay, yes. And actually we do transfer data from sender to receiver, right? Source to destination. So a channel helps us, or that acts as a path through which we can send data from the sender to receiver. Okay. Next one, board. Board is of course a technical terminology. It might be somewhat unfamiliar to you. Board. Okay. Board means simply what? Bits per second. That's what board is, right? And in networking devices you could see the terminology board, one board or board. Okay, yes, board simply means bits per second, and the number of changes in a signal per second is known as board. That means number of signal change per second, number of signal changes per second is called a board. Then it is a measuring unit of data transfer rate. Technically, board refers to the number of discrete signal elements transmitted per second. That means one board represents only one signal change per second and is equivalent to, of course, bit per second. Bit per second means one bit transmitted per second, right? One bit transmitted per second from the sender to the receiver, and board is equivalent to BPS, bits per second. Okay. Board is the technical term. That's the difference. The most commonly used term is BPS, bits per second. KBPS, MBPS, GBPS, all that, right? Yes. But board is a technical term. Board is equivalent to bits per second, BPS. Okay. That means the number of signal changes per second. That means one board means one signal change per second. Okay. Yes. Next one, bandwidth. Bandwidth simply means width of the band. Okay. Width of the band. Just like our local road and NH. Okay. National highway. You know the difference. Our local road, it's somewhat narrow, right? 3 meter, 4 meter. It's narrow width, right? But bandwidth means having 12 meters or 14 meters, 16 meters. That means it is having what? Huge width, right? So what is the advantage of having huge width? A lot of vehicles can be what travel at a time, right? And it has such a carrying capacity. Of course, speed also increases because it has such a wide width as well as data carrying capacity will also be higher, and the speed will also be getting increased. Okay, yes. So bandwidth means the amount of data that can be passed along a communication channel in a given period of time. Okay, you have to know that in a given period of time is termed as bandwidth. That means the amount of data that can be passed along a communication channel in a given period of time. Okay, that means 1 second. That's a common standard. 1 second. The measuring unit is of course hertz. Okay, frequency. Yes, where 103 hertz equal to 1 kilohertz. Okay, then 103 kilohertz equal to 1 megahertz. Yes, you know these are some of the units. Okay, so bandwidth simply means the capacity or the amount of data that a transmission medium can carry for a given period of time. Okay, for a fixed period of time, how much data a transmission medium can carry. That's what bandwidth is. The width of the band. Okay, yes. Then data and signals. Data means what? That is a passive entity, right? Data is what actually that is what we want to transfer from the sender to the receiver, right? And data is a passive entity, and signal means data when at the time of transferring, sending, and it travels to the medium, right, in the form of signal, especially electric signals, because we make use of copper wires, right? Yes. So data is converted to signals. Data is a passive entity, that is what we store in our computer, and that data is passed to the destination. So using through the communication channel or through the path, it is transferred or it is passing as signals. Okay, electric signals. Yeah. Then let's look at the definition. Information that is stored within computer systems and transferred over a computer network. That can be divided in two categories, data and signals. That means information that is stored in a computer system, that's what actually data is, and transferred over a computer means computer network can be, okay. Data are entities that are stored in the form of ones and zeros. We know that, right? Computer stores data in the form of ones and zeros. Computer can store anything in each and everything only in the form of ones and zeros, which conveys some special meaning to the computer system. Of course, it is a coded form. Data stored in the coded form, ones and zeros. When the data is transmitted from one place to another place, it is converted into signal. Okay. Here comes a role of signal, meaning I've already told you data is just a passive entity. That is a form. Computer stores the content, right? Yes, and it stores data in ones and zeros, the coded form, and just at the time of transferring it to the destination, that means passing through the wire or to the cable, it will be what converted to signal, right? Yes, it is converted to signal, and signals are the electric or electromagnetic encoding of data that are used to transmit data. Okay, because data is normally passed to copper wires. Okay, so it should be it can be passed only in the form of electric pulses, right, or electromagnetic encoding of data. So this is what actually data and what signals are. Okay, yes. Then communication or transmission media. Media means of course that helps in data transmission. It is a means of communication or access, lines of communication set up between two organizations to exchange data information. Communication media is a way of transmitting the signal from one place to another place. Okay, it is the way, it is a path, it is a route of transmitting signal from one place to another place. And communication media is also known as transmission media. It plays a very important role, vital role in sending and receiving data from to and fro from the sender and the receiver. And communication or transmission media, actually there are two media, wired media and wireless media, right? Wired media means there will be a physical connection between the sender and the receiver. It may not be most of the time, it will not be direct, right? Yes. Okay, we do follow client server architecture, and between we will have a number of servers and we are connected to that server. It will be stored for a temporary time and forward it to the next. Okay, that is what actually happens here in internet communication or network communication, having a huge number of computers and machines. Okay, yes. But okay, that's what transmission media, wired media is, right? We can call it as guided media. Okay, wired media or guided media having some physical connection. But in wireless media, that's the second one. Wireless media or unguided media, which does not have any physical connection, okay, which make use of radio signals or microwave or infrared for communication. That's the difference. Okay, so communication media or transmission media is a means of communication or that set up between two organizations to set or exchange data. Okay, yes. Then data transfer rate. We have already seen data transfer rate, bits per second, right? And the technical terminology is baud. Yes, it is the amount of data transferred in one direction over a link, divided by the time taken to transfer in bits per second. The various measuring units are bits per second or bytes per second. It can be, you could see the difference, right? When we write small b, it stands for bits, and when we write capital letter B, it means byte. Okay, always remember this. Small b stands for bits and caps B for bytes, or we can say baud. Okay, kilobits per second, megabits per second, gigabits per second, terabits per second. Okay, peta, yeah. It goes on like that. Okay, so data transfer rate means the rate of transferring data. Okay, usually it's measured in bits per second, or we can say baud. Okay, but as I told you, the most commonly used terminology is bits per second, BPS. Okay, then we have BPS and BPS. BPS small, bits per second, B caps, bytes per second, and kilobits per second, megabits, terabits, petabits, gigabits. Okay, yes. So these are the main technical terminologies. Okay, channel, the path helps in data transmission. Baud, number of signal changes per second. One baud means one signal change per second. Bandwidth, the carrying capacity for a given period of time. Data and signal, data passive entity, that's what's stored in the computer in the form of ones and zeros. And when you want to transfer it to the another place, it will be transferred in the form of signals. Okay, electric pulses, electromagnetic or electrical signals. Yeah. And communication transmission media, of course, wired and wireless media, that helps in data transmission. Okay, then data transfer rate, the rate through what the rate of transferring the data, right? The rate of transferring the data usually measured in bits per second, kilobits, megabits, gigabits, terabits. Okay, yes. Now we have our second topic, and of course it is a very important topic, network devices, and we do establish networks not only using computers, right? We need some other devices for establishing a network, computer network, and these devices acts as plays vital role in establishing a network, okay, other than computers. Of course, computer is a must, but along with computers or along with machines, these all devices plays a vital role, okay, play a vital role. Yeah. So we have modem, RJ45, Ethernet card, hub, switch, router, bridge, gateway, repeater, and Wi-Fi card. Okay, we have 10 specific or devices for discussion. Okay, the specialties, you could see all these devices at your home, at, in the school, everywhere you could see most of these devices. Okay, yes. So let's start with modem. A modem is a communication device. That's the most commonly used device you could see when you establish an internet connection, right? Yes. Otherwise, ISP, Internet Service Provider, provides us with a modem. Okay, provides a modem. Okay, yes. A modem, it stands for modulation, demodulation, or we can say modulator, demodulator. Here comes modulator, demodulator. Okay, it's an electronic device that enables a computer to transmit data over telephone lines. Keep in mind, it enables a computer to transmit data over a telephone lines. Okay, it is a device used to convert digital signals to analog signals and vice versa. There are two types of modems, internal modem and external modem. Okay, one that is provided by the ISP, and one by the from the user end. Okay, yes. Then modem stands for modulation, demodulation. Okay, modulator, demodulator, and it performs two basic functions: modulation and demodulation. First, we look at modulation. Modulation is the process of converting digital to analog. Okay, please never go in trouble with this, confusing with this. Okay, I'll make it more clear. Modulator, MOD. Here the terminology starting means ending with D, right? MOD, and the definition itself is also starting with D. That is digital to analog. Okay, yes. MOD, mode, ending with D, and definition starting with D, starts with D, that is digital to analog. Okay, so modulation is the process of converting digital signal to analog signal, and demodulation, of course, analog signal to digital signal. You just remember, memorize only one. Okay, because just at the time of getting into both these terminologies, it may definitely end into a confusion. Okay, so just get into only one definition, that modulation, digital to analog. Okay, demodulation, analog to digital. And what is the importance of converting analog to digital and digital to analog? Actually, suppose we are sending something to our friend, okay, using our computer, and she's also having computer, okay, machine. Yeah. So from our end, we send hi WhatsApp, right? Hi WhatsApp. Okay, that's the message we are sending. So how it happens is, we'll type, okay, WhatsApp, WhatsApp, okay, WhatsApp, yes. It will be we'll type it, and we'll press enter. Okay, and it goes to what? Now the signal is in which format? Digital, because computer can perform everything in digital format. So it moves to what? The modem, and modem converts the digital signal to analog signal. Why? Because through modem, just after modem, we have copper wires, right? Copper wire or some other kind of, okay. So copper wire can transmit only analog signal, right? We have seen it in our previous session. It can transmit only it can transfer only analog signals. So it should be converted. A computer has data in digital format, and that should be converted to analog format, just because it is carried over through copper wire. Okay, and just after reaching at the destination, your friend's computer, there will also be a modem, and that modem converts. Now the signal is in which format? Analog format, right? Yes, now the signal in analog format, and your friend's modem convert that into digital format again, because there is also a computer. Okay, your friend is also having a computer, and computer can read only ones and zeros. Now the signal is in analog, and that should be converted to digital. Okay, just for reading it, right? Yes, that's what modulation, demodulation is. It is very simple. Okay, yes. Next one, RJ45 connector. RJ stands for registered jack. Okay, RJ45 connector is a standard connector, a standard type of connector for network cables. The RJ45 registered jack connectors are used to plug-in devices, are the plug-in devices used in networking and telecommunication applications. These are used primarily for connecting LANs, particularly Ethernet. Okay, RJ45 is a short term for registered jack 45. It is an 8-wire connector used to connect computers on LANs, especially Ethernet. Okay, you know what actually RJ45 is? Okay, at the back side of your CPU, there is a what network interface card, right? Ethernet card, and your what that white cable, white cable, okay, coming from the modem. We are plugging into the at the back side of your CPU, right? And that place is called what? Ethernet card or network interface card, okay? And the connector, that connector, that glass type connector, right? It has 8 pins, okay? It has 8 pins, and that is what plugging into that port, okay? That connector is called RJ45, okay? That lightweight glass type connector is called RJ45, okay? Yes. And we have another connector RJ11, and it's mainly used in telephone, okay? And it has only four wires, okay? 4-wire connector, yeah. RJ11. RJ11 is used, that's a small one, very small one, right? Yes. And it's used in normal telephone, okay? Connected to our telephone, land phone, okay? Yes. That's what RJ11 is, and it has only 4 wires, 4-wire connector, okay? And here RJ45 is used to connect Ethernet cable or LAN cable, we can call it as LAN cable, okay, to the what CPU, or to specifically we can say what to the Ethernet card, okay? Yes, hope we get it. RJ45, the standard connector, glass type connector, okay? Yes. Next one, Ethernet card. It's a hardware that helps in the connection of nodes with within a network. Ethernet card, also known as network card, okay, or network interface card, network adapter, okay? It's a card that allows computer to communicate over a computer network. On Ethernet card, a physical address of each communicating computer is mentioned. Physical address is known as MAC address, okay? Ethernet card is a card, network interface card, LAN card, or it's also called what? Ethernet card, okay? These are the 3 terminologies referring to the same thing, that card, okay? And what actually it does is what? Ethernet cables from some network will be connected to that card, and that card acts as a interface between your computer and the internet, okay? Your computer is on one end, and what? Internet comes under the other end, so it acts as an interface, right? Yes. It's also known as MAC address, okay? Also known as MAC address. MAC address means medium access control, okay? Address, it is related to the what to say, address, physical address, okay? Physical address, yes, physical address, okay? Yes. So this is about modem, RJ45 and Ethernet card. Then next we have 2 devices called hub and switch, okay? Hub, actually hub, here is a device, and it is a device. You can see number of ports, okay? Yes, number of ports. Then these computers and which are connected to these ports, okay? Not only computers, some other devices can also be connected to this. Yes. So all the computers are connected to this device, okay? This is it acts as a junction, right? It acts as a junction, and all the connections from various computers are what to say, joined, right, or combined in this single device called what? Hub, okay? Yes, hub is a multi-port. You could see multiple ports, right? Multi-port and unintelligent network. It is unintelligent. Why? Because we are coming to it, okay? It's a multi-port unintelligent network device which simply transfer data from one port to another port, okay? Port of a network to another. A hub is a hardware device used to connect several computers together with different ports, okay? Hub is a hardware device used to connect several computers together with different ports. When a packet reaches one port, it is copied to all other ports of the hub. Suppose one connection comes here. What actually hub does is it copies what? Copies the data or the address, everything to all other ports, okay? Without changing the destination address in the frame. Frame is a part of the message, okay? The data. Rather, it simply copies the data to all the nodes connected to the hub. Yes. Actually, it doesn't do anything big. It simply copies the frame or the address or the data to all the nodes without even checking the destination address, right? Yes. And hubs can be either active or passive, okay? Hubs can usually support 8, 12 or 24 RJ45 ports, okay? It can be having 8 ports, 8-port hub is there, 12-port hub is there, 24 ports hub is there. That means 8 ports hub you can connect only 8 computers or devices, 12 devices, and 24 devices, that's it, okay? But the problem with the hub is that it is not intelligent device. It's not an intelligent device. It share bandwidth with all the attached devices and broadcast the data, that is sends the data frame to all connected nodes, and it does not remember the devices computers connected to it, and also it cannot filter the data and causes unnecessary traffic jams. Okay, actually the problem with hub is it copies the entire information to all the ports, okay, and without even checking the destination address or anything else. Okay, so it shares the bandwidth with all the attached devices and broadcasts the data, sends the data frame to all the connected network. Okay, it doesn't remember the devices or computers connected to it. That's a problem. Okay, it doesn't remember the computer or the address of the computers or devices connected to it, and it cannot even filter the data. Okay, it cannot even filter the data, so it causes unnecessary jams. A hub can both send as well as receive information, but only one task at a time. Okay, it's another problem. Only one task can be performed at a time. However, hub is inexpensive way to connect. Okay, so most of the time hub and switch are used interchangeably. Okay, so no problem, but switch is somewhat intelligent than hub. Okay, hub is a device used to connect several computers with each other. So this is what actually a hub is. A hub acts as a junction where all the Ethernet cables from different computers are joined joined. Okay, and what actually happens is hub copies all the information to all other nodes. Okay, it doesn't even check, it doesn't even remember the address or anything. Okay, yes, the address of other computers or the data. So it cannot filter the data as well. So it causes traffic jams. Okay, yes. It is inexpensive though, so this is the most commonly used, of course. Okay, other than switch. Yeah, switch and hubs are most commonly used. Okay, yes. Next one is switch. Switching hub is a network device which is used to interconnect computers or devices on a network. It filters and forwards data packets across the network. That is what actually hub also does. Okay, then it is also a multi-port device. Okay, it's also a multi-port device, but with some intelligence. And so the data packets received from one port to network are refreshed and delivered to other ports of the network. Okay, the main difference between hub and switch is that hub replicates what it receives on one port to all other ports, right? Yes, hub replicate or copy to all other nodes, all other ports, while switch is a device that transmit. Yeah, while switch keeps a record of the MAC address of the device attached to it. Okay, switch can remember. Okay, it can remember, it has a capacity to remember what the MAC address, that means the internal or the physical address of other devices attached to it. A switch is a device that transmits data to a computer in a LAN. Okay, yes, so these are the difference between hub and switch. Okay, both are multi-port devices and both are used to have connection from multiple devices and acts as a junction. And the difference is hub is an unintelligent machine device and switch is an intelligent device. And hub, what does is it copies or replicate the address or what it receives, okay, to all other nodes, but which cannot keep tracking what the address or anything. Okay, yes, but a switch can. Switch has a capacity to keep track of the record of MAC address and everything. Okay, yes. So these are the differences. Okay, there won't be much jam here in switch. Okay, then bridge. Actually, what is a bridge? What is a real-time bridge? Real-life bridge. Okay, actually, bridge used to connect two different places, right? Yes. Here in networking, bridge is a device that works on physical layer as well as data link layer. Okay, what are these layers? Actually, we do follow ISO OSI. Okay, ISO OSI, International Standards Organization. OSI, Open Systems Interconnection. Okay, it is an architecture. Okay, it is a generic architecture followed in networking. Actually, there are two architectures. Okay, one is ISO OSI, Open Systems Interconnection, and the second is TCP/IP, Transmission Control Protocol, Internet Protocol. And ISO OSI consists of seven layers. Okay, PDNT SPA, physical. All these are layers. Okay, physical layer, data link layer, PD, and network layer, transport layer, PDNT SPA, session layer, presentation layer, and application layer. Okay. Physical, data link, network, transport, session, presentation, application, 7 layers. But in TCP/IP, it's a specific one. Okay, the OSI is a generic one, and TCP/IP is derived from OSI, and it has only 5 layers. Okay, yeah, physical, data link, network, transport, and session, presentation, application together to form application layer. Okay, so total 5 layers. And bridge actually works on both physical layer and data link layer. Physical layer deals with what? All the physical medium, okay, like cables, okay, all those kind of things. And data link layer used to link the data. Okay, yes. So bridge belongs to these two devices. Actually, bridge is a device that connects devices from different networks that follow the same protocol. Okay, actually we have two devices, bridge and gateway. Okay, bridge and gateway, just like hub and switch. Okay, there is difference between bridge and gateway. Bridge connects different LANs following the same protocol. Bridge connects different LANs, local area networks, that, or we can say simply networks that follow same protocol. But gateway is a device that used to connect different LANs following different protocols. Okay, bridge connecting multiple networks following the same protocol, and gateway connects multiple LANs following different protocol. That's the difference. Okay, yes. A network bridge connect multiple network segments at the data link layer. It's a layer 2 of OSI model. Okay, yes. Bridges relay frames between two original separate segments. Okay, when a frame enters a bridge, the bridge not only regenerates the signal but also check the physical address of the destination and forward the new copy only to that port. Okay, that means specific. It won't copy that signal or the address to all other ports. Okay, it's send it to the specific port. Okay, an important advantage of using a bridge is that it is smarter than hub. Okay, as it can filter network traffic on the basis of MAC addresses. MAC address is the exact physical address, okay, of the destination. A bridge is a device that links two segments together of the network, original network. Okay, so an important advantage of bridge is that it's smarter than hub. Okay, as it can filter network traffic, and it's used to connect different LANs of following same protocol. Okay, yes. Next one, gateway. A gateway is a device that connects dissimilar networks following different protocols. In internet, several networks are communicating with each other, and each other has a different configuration. In order to make reliable communication, there must be a device that helps in communicating. Okay, gateway is a device which establishes an intelligent connection between local area network and external networks, completely different structures. Okay, that means gateway is a device that connects different networks following different protocols. Okay, that's it. A gateway is a device that connects dissimilar networks. Dissimilar networks means networks following different protocols, but bridge connects dissimilar networks following the same protocol. Okay, that's different. Yeah. Next one is a repeater. Repeater, as the name suggests, repeater repeats a signal. Okay, strengthens signal, improve the quality, not the quality, strength of the signal. Okay, a repeater is a device that operates only on the physical layer of the OSI model. It operates only on physical layer of OSI. Okay, as a signal travels at a fixed distance before attenuation of the signal. Attenuation means losing the strength of the signal. Okay, attenuation is that means losing the strength of the signal. That means, okay, when something when the data is transferred or passing through any physical medium, copper wire or any kind of medium, after some distance, okay, after some distance, the strength of the signal will lose, definitely. Okay, so a repeater is a device that plays a vital role here in improving the strength of the signal. Okay, a repeater is used which amplifies and restores signal for long distance transmission. A repeater is an electronic device that receives a signal before it comes too weak and regenerates to original signal. That means it is used to amplify. It is used to amplify the signal whenever it's getting low. Okay, meaning whenever it is getting attenuation happens, right? Yes. Also, it is a two-port network device that strengthens the signal's intensity and connects to two identical networks. Okay. In most twisted pair Ethernet configuration, repeaters are required for cables longer than 100 meters. Okay. Just after reaching or more than 100 meters, the strength of the signal loses. Then at the time repeater will be installed. Okay. Then repeater does not change the functionality of the network. Instead, it makes only signal strong before it degrades. Okay. Degradation, to avoid degradation of signals. Okay. Losing the strength of the signal, we are applying this, installing this repeater. Okay, repeater is a device that amplifies the signal that is transmitted across the network so that signal is received in the same way it is sent. Okay, signal, that means repeater is a device that is used to strengthen the signal. Why strengthen the signals? Because after going through the medium for a long distance, the strength of the signal may be lose. Okay, there is a possibility of losing the strength of the signal. So it should be what, amplified. So here comes the role of repeater. Okay, we have another device called amplifier, right? Amplifier. There is a difference between amplifier and repeater. You know that? Amplifier and repeater. Repeater repeats only the signal. Okay, but amplifier repeats both the signal and the noise. Noise means unwanted disturbances. Okay, so amplifier, the device amplifier is which also strengthen or amplify the signal as well as the noise. Okay, here repeater will not repeat or amplify the noise. That's the difference between repeater and amplifier. Okay, yes. Then we have router. Router is a device that forward data packets from the source machine to the destination machine by using the shortest path. Routers are used at the network layer, which is a third layer of OSI. Okay, routers are used in network layer. A router is a network device that helps in forwarding packet from one machine to another machine. Okay, that means router is simply a device that shows the route, right? Router or router. Okay, router is a device that used to give the route from one point to another point. That's it. Okay, router works on network layer of OSI. That's a third layer, right? That's a third layer of OSI. And actually, modem, our modem, modulation, demodulation, modulator, demodulator, it consists of some other devices. Actually, all these are integrated, right? Like router will be there, gateway will be there. So modem acts as a multi-purpose device, right? Multi-functionality device. Modem does not only works like a modem, only as a modem. It works like a gateway, it works like a router. Okay, it has all these functionalities. Yes, always keep in mind that. Okay, yes. Then last one, Wi-Fi card. Wi-Fi card means what? Wireless fidelity card, right? Wi-Fi card is used to establish Wi-Fi. That's it. Okay, Wi-Fi card is either an internal or an external local area network adapter with a built-in wireless radio and antenna. Okay, with a built-in wireless radio and antenna. A Wi-Fi card is used in desktop computer that enables a user to establish an internet connection. Wi-Fi cards are known as wireless fidelity cards as they allow user to set up connection without any wire. So here comes the role of Wi-Fi card. Okay, suppose you have a machine, you have a desktop. Okay, not a laptop, desktop. The laptop will have built-in mechanism of Wi-Fi. Okay, so there is no extra feature is needed, right? Okay, so if here comes another point, that is if your laptop Wi-Fi is not working, you can install a Wi-Fi card to your laptop, no problem. But a desktop, okay, actually the need is of a desktop, right? Yes. So desktop will not have any most of the time there will not be any Wi-Fi card, okay, built-in Wi-Fi facility. So what we do is we'll install a Wi-Fi card. Okay, so it provides wireless fidelity. That's it. Okay, cards are widely used in notebook computers due to their highly portable nature. Okay, the most common Wi-Fi cards are used in desktop computers are PCI Express. Okay, that's a name. Okay, Wi-Fi cards are made to fit PCI Express card slot on the motherboard. Okay, so motherboard must also support this, right? Otherwise it cannot work. Okay, so this is about Wi-Fi card used to set up Wi-Fi in our desktop, mainly in desktop. Okay, as we have Wi-Fi, built-in Wi-Fi in our laptop, no need of that. Okay, but desktop, yes. So it's an adapter actually. Okay, so these are the devices. Okay, modem, RJ45, Ethernet card, hub, switch, bridge, gateway, repeater, router, and Wi-Fi card. Okay, so these all are very important topics. Just to go through this, as you could always see, this is all about the theory stuff, right? So you must go through this, right? Okay, so we have gone through what network devices as well as terminologies, advanced terminologies, right? Yes. So just go through all this. Okay, we can have some other topics like types of network, LAN, MAN, and WAN, and transmission media, topology, all those kind of things in our coming classes. Okay, so thank you for watching. Have a nice time. See you in the next video. Take care.